Okay, so we're going to look at this green digestive board model, which basically covers the entirety of the digestive system. So the digestive system as a whole begins at the mouth and continues on basically as a long tube that goes all the way down from the mouth to the anus. So within the mouth, there are several structures that are important for digestion, or at least the beginning part of digestion. The teeth, which we'll come back to in a few minutes on a different model. The tongue, the hard palate, which is bony, coming from the maxilla and the palatine bone. And then the soft palate here, which terminates as a little area called the uvula. And the uvula moves reflexively as you swallow to block food from going up towards the nasal passages. So at the back of the mouth, there is a space. It's not so much a structure rather than a space we just delineate based on where it is anatomically, called the pharynx. The part of the pharynx that's superior and is more associated with the nasal cavity is called the nasopharynx. From the uvula down to where the larynx, specifically the epiglottis, start, is called the oropharynx because it's more associated with the mouth. And inferior to that, we call it the laryngopharynx, to the point where this long muscular tube that goes down to the stomach, called the esophagus, begins. Now the epiglottis, I'm going to show you on another model to make it a little bit more clear, is sort of looks like a tongue. It's part of the larynx, and its job, if you notice here, this is where your airway begins. This is the esophagus. So as you swallow, the uvula moves superiorly to protect the nasal cavity. The epiglottis moves inferiorly to protect the airway going down to the trachea and bronchioles in the lungs. So we just want to keep food going in its appropriate location down the esophagus here. Now the esophagus heads down into the thoracic and abdominopelvic cavity. So as it travels inferiorly from the thoracic to abdominopelvic, it's going to have to pass through the diaphragm. So if you remember, the diaphragm, if we look at this model, is a muscular structure that separates thoracic from abdominopelvic, but it's also a major respiration muscle. So it passes through there and it creates a little opening called the esophageal hiatus. And I'll show you that on another video on another model. So the esophagus enters the stomach, which is a little J-shaped pouch. It's very, very stretchy, so it can change size very easily depending on how full it is from the food that you've just eaten. Now the area that the esophagus attaches to the stomach is called the cardia. So we call the junction, it's a little muscular gate, and you can kind of see it here on this model, is called the cardioesophageal sphincter. Again, sphincter just means muscular gate. So the cardia is the site of attachment to the esophagus. You have a dome-shaped superior facing portion of the stomach that we call the fundus. The word fundus always means dome-shaped. The bulk of the stomach is referred to as the body, and the portion that is in contact with the small intestines we call the pylorus. And we do have another sphincter that's a little bit more tight than the cardioesophageal sphincter. This one is called the pyloric sphincter, and it gates how much of the churned up food stuff that we're going to call chyme from this point on gets sent into the small intestines. Now you'll notice in the stomach it has a lot of wrinkles inside. Each of these wrinkles is called a rugae, and that just helps the stomach be able to expand whenever we eat a meal and contract back down. It also adds surface area that allows the food to mix with digestive enzymes that are released within it. Also, you can see on this model of the stomach that there are distinctive curvatures. You have a lesser curvature on the medial side and a greater curvature on the lateral side. There are muscular layers associated with the stomach, but we're going to cover that in another video where we have a little bit of a better model. Alright, so from the stomach, we're going to begin our journey down the small intestines first. Small intestines are smaller in diameter, but we have way more of them. The small intestines originate in a small little C-shaped area called the duodenum. You can call it duodenum if you like, and I'll take this old sticker off. Now the duodenum, as well as the majority of the small intestines, have these little folds inside called circular folds. And the goal of the small intestines is to take the food that we've eaten, which has been turned to chyme here in the stomach, and absorb all the nutrients from it. So these circular folds increase the surface area, so we maximize the potential for absorption. And along those same lines, it sort of acts like that gumball in the gumball machine in the restaurant you always wanted to use as a kid. It makes it slow down and spin as it heads through the small intestines. Now we're going to look at a histological model of the duodenum in just a minute, so hang tight for that one. Now, the duodenum is really short and C-shaped, and the pancreas kind of tucks right into it. So we're going to come back to this in just a minute, looking at the bile duct system. So from the duodenum, the next portion of the small intestines is known as the jejunum. The jejunum and the third portion, known as the ileum, are not easily distinguished from each other gross anatomically. There are some histological differences, but for us in this course, we're going to say if we tag it superiorly, it's the jejunum. If we tag it inferiorly, it's the ileum. Now at the ileum, it forms a little junction. This is called the ileocecal junction here. This is where small intestines becomes large intestines. So it begins at a little pocket called the cecum, which is also coincidentally where our appendix, the anatomical term is vermiform appendix because it looks like a worm, hangs off. Now the vermiform appendix will come back if you take 245 with the immune system, because that's where we think the function mostly lies for the appendix. So from the cecum, the large intestines will continue on superiorly as the ascending colon, across as the transverse colon, back down as the descending colon, and then it will make an S-shaped curvature before it forms the rectum, called the sigmoid colon. So rectum is the terminal portion, and then it becomes the anal canal, which has anal columns associated with it. Also structurally with the large intestines, you see those little pockets that form. Those little pockets individually are known as haustra, and they're tensioned together to form those pockets by these little longitudinal muscles, specifically smooth muscles called taenia coli. And as these taenia coli, the muscles inside contract and relax, we can move the boli or bolus of fecal matter forward and project it towards the anal canal. Now at the anal canal, we have another set of sphincters. Again, these are controlled differently. The outer sphincter, known as the external anal sphincter, is made up of skeletal muscle. The internal anal sphincter is made up of smooth muscle. So smooth muscle is involuntary. We can't control opening and closing by thinking about it. And the external anal sphincter is what we learn to control during potty training whenever we're a little toddler.